In today's lesson, we are going to see a short introduction to virtual reality development. First of all, please download the progress that we have done so far. I have made a couple of fixes in this code, so you should download it. So what we are going to do in this lesson is to adapt our project to also work in VR. In order to do it, we are going to use the Oculus SDK to develop for Oculus Quest, because right now it's the most popular headset in the market and it provides the best development tools of all the existing options out there. You have to consider that gaming in VR is a niche market, okay, where mostly sports and musical games are the best sellers right now. But outside the gaming field, I am talking about simulation, training, showcasing products, there is a big demand of professionals. So learning VR will open a lot of job opportunities. But before starting importing the Oculus SDK, we are going to do some changes in order to ease the process of also developing for VR. So now what we are going to do is that we are going to create most of the controllers in runtime. Okay, so far we have all the controllers in the scene. And what we are going to do is just to instantiate the controllers. We are going to convert them to prefabs. And in the GameController script, the one that will remain in the scene, it will be in charge of creating all these controllers. Okay, the reason for this action is to have the minimal number of dependencies in the scene. Okay, that will allow us to make our work easier when working with multiple colleagues and also in the process of developing for multiple platforms. So let's convert all these controllers to prefabs and remove them from a scene. So the instructions I am going to tell you are the ones that you need to do in order to convert and instantiate all these controllers. First of all, you need to convert all the controllers to prefabs. Just create a new folder in resources controllers to place all these prefabs. And you are going to convert all the controllers except the GameController. Okay. In the GameController script, just create a new public array of game objects that you will fill with all the previous prefab controllers. In the GameController script, in the awake function, you are going to instantiate all the controllers that are in that array. The next thing that you are going to do in the camera controller script, you are going to change the public member variable game camera to a private member variable game camera. And you are going to create a getter to access that will have the same name as it had the previous public member variable. That way, anything that we're referencing to the game camera will still be working. Finally, in that previous getter that you have implemented, you would check if this private member variable is null, then you will look for the camera, okay? And you can look for the main camera, just like this, camera main, and you will instantiate this variable if this variable is null, okay? And finally, you would return the variable in the getter. So go ahead and do it. And the result should look similar to this. What we have first done has been just to convert all the controllers except the GameController to Prefabs. Okay, next we have created for the GameController the public game object array that will contain all the previous controllers, and on the wake method we are just instantiating each one of the controllers. Next, on the camera controller, what we have done, we have converted the previous public member variable game camera to a private member variable, and we have created a getter with the same name in order for all the references to the game camera to keep working. In the getter, what we are doing is we are checking if this member variable is null, and in the case that is null, we search in the scene for the game camera and initialize the previous member variable. And finally, we return that variable. If everything is right, we should get exactly the same behavior as before, but this time all the existing controllers have been instantiated in runtime. This will help in the process of creating multiple configurations to deploy for multiple platforms. So now that we have reduced the dependencies with the scene, we have a better scenario to include the VR platform. So now in the Unity asset stored, you are going to search for Oculus Integration, and you are going to import the package into your project. So if we go to the Unity asset store and look for Oculus Integration, we should get the package we are looking for. It's a free package. You can add it to your assets and open it in Unity. Download it and import the package. Okay, once you have imported the Oculus SDK integration in the project, you would have a folder called Oculus in the assets folder that will contain all the necessary resources for you to develop for Oculus Quest. So next, what you are going to do is that you are going to download the Oculus companion app. So if you go to the official Oculus Quest MetaQuest website, you will have a link to download the software in order to be able to connect your Oculus Quest to your PC, so you can develop directly with your Oculus Quest connected to your PC. Okay, so install it, and the final thing that you need to have is you need to have an Oculus Quest headset. Any version of Oculus Quest headset works. So if you find a good offer for an Oculus Quest 1, go for it, and if not, there are different prices for Oculus Quest 2. For the next step of the lesson, I am going to guide you through it, and what we are going to do is to add to the scene the necessary elements in order for the VR version to work. So first of all, we need to save the scene game in the folder, in a new folder that we are going to create right now, that will be called Oculus, and we are going to save it with exactly the same name. The reason why we need to use the same name in order to save the scene is because Photon requires that all the connected clients scene should have the same name in order to the multiplayer to work. So let's save our scene in the new folder, in the scenes folder. Okay, here we create a folder called Oculus, and inside here we just save the current scene with the same name. Okay, so now we can proceed to add the necessary elements for the VR version to work. So first, open the Oculus folder, then here the VR folder and the Prefabs folder. And here there is a collection of utilities that are commonly used. The one that we are most interested is Ovr Camera Rig that will provide just all the necessary elements in order to control the VR camera, plus the controllers. Okay. In here there are more complex elements that can manage even more functionality, but for our case we are going to keep it simple, and this is the most bare bones element that you need in order for the VR to work. Next thing, we are going to remove the main camera, because the main camera is included right here. Okay, it's in the center eye anchor, it's here, so we don't need the camera anymore because we have it in the camera rig. The next thing that you are going to do, we are going to add another prefab from the folder Oculus sample core debug prefabs, and we are going to add UI helpers. Okay, this as the name says will help in the process of interacting with the world. And we are going to change in the event system, in the property ray transform, we are going to assign it to the right controller anchor. Okay, right here. And setting the ray transform in the OVR input module will provide us a way to interact with panels with the world. Okay. Next, on the laser pointer, you are going to enable the line render. So we will be able to see a line that will help us to interact with the world. Next, on project settings, we are going to add, okay, let's go to project settings, and in XR plugin management, you are going to install the XR plugin management. And you are going to select for both Windows configuration and Android configuration to work with Oculus. Okay, you have to remember that the Oculus Quest runs in an Android-based operative system. So when you finally deploy a build, it's basically an APK file, like the ones that you can create when developing for an Android mobile phone. And you would need also to support Android. So now in the input controller script, we are going to create a private member variable that will keep the information about if we are working or not in VR. Okay. And we are going to create a public getter for it. Next, in the same input controller script, you are going to create a public method called initialized that will set the previous variable. Okay, it will look for the Ovr Camera Rig, and if it is on the scene, then this boolean variable will be true. If not, it will be false. And finally, what you are going to do is to call this initialize method on the start method of the GameController script, just before the GameController changes to the initial state. So go ahead and do it. Okay, and the result should look similar to this. We have started in the input controller script. We have created this private member variable that would keep the information about if we are working or not in VR. And in this initialize method, we are just looking for the Ovr Camera Rig, and if we found it, then this variable would be true. Next, on the GameController script, we are just calling that previous method initialize in order to set that previous variable. So still in the input controller script, what we are going to do is to adapt the inputs. So instead of getting the keyboard input when we are working on VR, we are going to get the Oculus controller inputs. Okay, I am going to highlight that back in the lesson of solid principles, the work we did with the principle of single responsibility was to move all the inputs to its own manager, that it was the input controller. So right now, the work we did on that lesson, we are going to take advantage of it, because it's going to be totally transparent for the rest of the system to know where the inputs come from. The rest of the system simply won't care or won't know if the inputs come from the keyboard or any other device, like it is in this case the Oculus controllers. So what you are going to do, I am going to provide you with the methods that get the input from the Oculus controllers, and you are going to use them when you are working in VR mode. Instead of using the keyboard input, you are going to use the VR input. I am going to describe these methods. Okay, so the method getJoystick gets a vector2 with the coordinates that the joystick is being pressed, and we will use that information in order to move. Okay, this function getHandTriggerDown checks if the button of the hand trigger has been pressed, and the method getIndexTriggerDown will get if the index trigger has been pressed. Okay, so go ahead, copy these methods into the input controller, and what you should do is just, instead of using the keyboard inputs, and when you are on the VR configuration, instead of getting the inputs from the keyboard, you are going to get the inputs from the Oculus controllers. So go ahead and do it. Okay, and the result should look similar to this. What we are doing is just checking if we are working in VR, this private member variable would be true. And if we are on VR, instead of getting the input from the keyboard, we are getting the input from the Oculus controllers. For the case that if any key has been pressed, we get the joystick, and if any of the coordinates of the joystick is different from 0, we return true, else we return false. For the axis, we are getting the X component of the joystick. For the vertical axis, we are getting the Y component. And for the jump, we are getting, we are using the hand trigger to detect when the user wants to jump. And for the shoot, we are checking the index trigger in order to check when the user wants to shoot. So now we are going to go to the screen controller script, and we are going to do the necessary changes in order to create the screen so we can see it and interact with it in VR. Okay, I am going just to provide you the code, and we are going to analyze it. So just follow me, copy these codes, go to the screen controller, and just below this line, when you have just added the screen, you're going to add this code. Okay, and don't forget this constant. Okay, and what we are doing here is, okay, we are checking if we are or not working in VR, and if we are on VR, we need to set the canvas to wall space, okay? The wall space, the render mode, if you set it to wall space, it becomes not a UI that is just in the screen, but an element that is in the wall. The next, in order to interact with this element, we need to add the Ovr Raycaster. And in here, we are just placing this new screen just in front of the player, okay? And we are just doing it by getting the position of the camera and the forward vector that is currently looking the camera, and just placing that screen just in front of us. Finally, we need to scale that screen. That's why the constant. And in this case, you need to do a really big scale down in order for the screen to be something normal. The next thing we need to do before doing our first test in VR is to move the Ovr Camera Rig inside the player, because when we move the player, we are interested that the VR camera is inside it, moving alongside. Okay, so on the camera controller script, we are going to code this getter that will give us what needs to be moved inside the player. Okay, so go to the codes, copy paste these methods in the camera controller, and just below the getter of the camera, copy this method and create this as a private member variable, game object. This would be the reference to our VR camera rig. The next thing that we need to do is that, okay, we need to put this camera, this Ovr camera rig, inside the player, okay? And in order to do it, we can have this event, okay, that it will report when the player is ready. And when the player is ready, then we would be able to add the previous XR camera rig inside the player, okay? And we are going to do that just like this. And first of all, check that you are working in VR, okay? So input controller instance is VR. So if we are in VR, we are going to put the Ovr camera rig inside the player. So when we move the player, also we will move the Ovr camera rig. Okay. The next thing that we need to do is, okay, we have to prevent some functionality to when we are working on VR. In this case, we need to prevent just changing the forward vector camera. So if we are on the case of running in VR, we should prevent from changing the forward vector camera. Another change that we need to do to prevent undesired behavior when we are running on VR mode is this one. On the player script, in the method rotate camera, we need to check if we are on VR mode, because if we are on VR mode, we should prevent this functionality from running. Okay, so go to the code, and for the player script, for the method rotate camera, you are going to check if we are working in VR mode, and if we are working in VR mode, this is not going to run. Okay, so now it's time to test it. If you have your VR headset, just wear it and start the connection with the Oculus Link. Once you start the Oculus Link, you would see that the companion app in the PC has been started. Okay, and now we can proceed to run the application. Okay, so we can see the main menu screen in the 3D wall, and we can select play as a single player. And now we are on the game. We can move with the joystick, okay. and we can jump with the hand trigger, okay, and we can shoot, but we are shooting just the shooting is wrong. This is something that we are going to fix right now, but related to the movement, the jumping, and detecting the triggering of the buttons is working fine. So now let's solve the problem of the shooting. So instead of using the forward vector of the camera, that we can use the hand controller. So in the input controller script, you are going to copy paste this getter. Okay, so go to the code. In the input controller script, you are going to add another getter. Okay, if this private member variable is not there, just create it. Private transform pointer view. Okay, and import the necessary libraries. Okay, so what do we have here? What do we have here? It's just a reference to this ray. Okay, the ray that allow us to interact with the world. And we are going to use that forward vector of that ray in order to know the position and the forward vector and the direction of the bullet. Okay, so that's what we get with this getter. We are looking for the OVR input module and we are getting that ray, the transform of that ray. With that information, we have the position of the hand and the direction we need to shoot the bullet. So go ahead and use this information. So in the player, instead of using the current camera vector, use that information. Okay, so go ahead and do it. And the solution should look similar to this. We are just checking, okay, we are on VR, and if we are on VR, we are getting that ray to use its position and its forward to set the position of the bullet and the forward vector that the bullet should go. If we save and proceed to run, now if we shoot, as you can see, we are shooting in the direction of the ray. Okay, let's kill some enemies. Okay, let's kill this one. Okay, so it's working. We run out of bullets, so let's look for bullets. So now we are going to do an exercise, and this exercise would be about creating the script called rotate VR camera, and we are going to create that script in a new folder called VR inside the scripts folder. And the goal of this script is going to be to rotate the camera 30 degrees in both sides, left and right. Why do we need to do that? Because having a way to rotate the player in the game would avoid us to having to turn around ourselves in the real world. Because you have to consider that the user could be sitting down in a chair or on a sofa and he's not able to move freely around. So by this way, we are going to enable in this case the right left joystick in order to use it. So when the user press the right joystick left and right, the player is going to rotate this 30 degrees one side or the other. So finally, this component would be attached to the Ovr Camera Rig. Go ahead and do it. And the solution should look similar to this. What we have first done, we have created the new script, rotate VR camera, and we are offering this private member variable through the inspector, so it can be customized. And this value would be the degrees that the camera is going to turn around every time the user presses left or right in the right controller joystick. Okay. And what we are doing here is just in the update method, we are checking the right thumbstick, getting the values on X and Y, and we are checking that if the X value is above 0.5, then we would consider that as that the user has pressed the thumbstick to rotate, and we would apply a rotation either on one direction or on the other. Okay. And finally, we have added this this component to the Ovr Camera Rig. If everything works as expected, so now I can use the right thumbstick to rotate right and left. Every time I use the right thumbstick in one direction or another, I am able to rotate. By this way, I don't need to turn around physically in order to be able to run the game. I can do it just with the two thumbsticks. The left thumbstick to move around and the right thumbstick to turn around. So in this last part of the lesson, we are going to see some techniques that will help us in order to deploy for multiple platforms. As computer programmers, we are going to be requested to support multiple platforms. What we are going to do right now is to show a way to do it, to create a desktop version and a VR version. In order to do that, we are going to use preprocessor constants to help us out to differentiate between these two versions. What is a preprocessor constant? It is a constant that is being processed before the compilation. So this feature will allow us to just enable and disable some code before the compiler takes care of it. And how we do that? Okay, to create a preprocessor constants, let's go to the project settings. So go to the code, and in the project settings, in the player section, there is this section of script compilation, scripting defined symbols. So far, there are 3 preprocessor constants that are actually being used by Photon. But we are going to add our own preprocessor constants. And the first one that we are going to add is a custom one that we will call enable Oculus. Okay, so we are going to press plus and we are going to create enable Oculus. Okay, we are going to apply the changes. And by applying the changes, if the compiler finds that there are constants in the code, it gets them before the compilation process. Okay, that will help us in order to, in this case, exclude anything related from Oculus to create the desktop version, because in the desktop version we are not interested that anything from Oculus to be there. So that's the reason why we are defining this preprocessor constant. Okay, so now we can go to the code and as an example, for example, let's go to the input controller script, and in here the first change that we can do in order to start encapsulating anything related with Oculus is just in the initialize method, just use this preprocessor constant to encapsulate this code. So what would happen? What would happen is that, okay, if this preprocessor constant exists, that means that in here, in the scripting defined symbols, there is an entry with that specific name, then this code is considered. This code is included in the compilation process. But if this preprocessor constant is not there, then this code won't be included. Okay? This would be the solution in order for the desktop version to be able to remove anything related with Oculus. Okay? So now it's the time for you to go through all the elements that are making reference to anything related to Oculus and encapsulate them inside this preprocessor constant. So what you should do is just to go ahead and in all the places that you are using Oculus, you are going to cover that cases. For example, in the get joystick, instead of calling the method to get the values, you are going to return just 0. So go ahead and do it. Okay, now that you have encapsulated all the reference to the Oculus libraries in this preprocessor constant, now we are going to create a new copy of the project and we are going to copy it in the folder client. So go to the folder and in here you are going to create a copy, copy paste and create a new copy. Once you have the copy, you are going to call one of the clients desktop and the other client quest. Okay? And from the desktop client, you are going to make sure that the Oculus library is not there. Okay? And in the quest client, you are going to make sure that the Oculus library is there. Okay? Now you are going to open both projects and you are going to make sure that the preprocessor constant enable Oculus is not on the client desktop version. But in the case of the quest client, in this project, the preprocessor constant enable quest is there. Okay, so go ahead and let's make sure of that. Open the client desktop version. Okay, now that we have opened it, we notice that we have missed something. Okay, so let's go to fix it. So you are going to open the original project and in here you are going to fix to encapsulate what we have missed on the screen controller. So go to the screen controller and in here, in the case that if we are using VR, okay, we need to add the code related to VR functionality, but in the case that we are not needing, then we don't need, okay? Then use the batch process just to copy to the right folder, okay? Now we have to create two entries, one to make a copy to the desktop copy, and another copy to the quest copy, okay? Okay, so once you have it like this, make the copies from one side to the other and go back to your project. And so here there is no longer any error and we can proceed to run the normal scene, the original scene, okay? The one that doesn't have the Ovr Camera Rig. and you can run it and it should work as always. Okay, so this is working fine. Before proceeding running the two Unity instances together in a multiplayer match, I need to just to highlight that I have made some mistakes and I tell you how to fix them. Okay, first of all, when you are running multiple Unity instances, you are going to create multiple players, and the code that we had to deal with when the camera controller was listening for the player to start in order to add the Ovr Camera Rig inside the same player was a bad approach. Okay, so this is one part of the fix. Okay, right now, first of all, if it's not a multiplayer game, it gets initialized, and now we are not putting the Ovr Camera Rig as a child of the player. And if we are on multiplayer mode, we are only setting up the mPlayer private variable only when we are the owner of that player. Okay. The other change has been, okay, now the container that handles both the Ovr configuration and the normal camera is the one that it gets the position updated. And when we are working on VR, we set the forward vector of the player with the data that we get from the Ovr Camera Rig. And if we are not working in multiplayer, we set the forward vector of the camera as we did previously. Okay. The next change that we have done in the interface, we have added a set for the forward camera, and in the player we have implemented that set, and we are setting the forward vector of the player. Why we are doing this? Because on VR we are interested to use the Ovr Camera Rig forward vector for the direction that the player is looking. Okay, so now we can proceed to run both Unity instances. So save everything, move the changes from one side to the copies, and proceed to run first one client. It doesn't matter which one. We will start with the VR client. Just make sure that you are on the right scene. Okay, the VR scene. Select multiplayer. Okay, move away from the start position and wait for the client desktop client to join. So we are going to join with the other client. We are joining. Okay, so if we get close to the other player, okay, so now I am turning the head to one side of the and the other, so you can see that also the avatar is moving, is turning around at the same time as I do. Okay, I am going to also move the VR avatar. Okay, now I am moving the VR avatar. I am jumping with the VR avatar. Okay, and I am going to take control of the desktop avatar, and I am going to move the desktop avatar. Okay, so I am jumping with the desktop avatar, so the synchronization is working fine. So now that we have tested both Unity clients, we have to make a change in order to be able to deploy a build for the Oculus Quest. As I told you, Oculus Quest is an Android headset. So what we need to do is, first of all, open the client Quest. And in this project, we are going to, first of all, make sure that the preprocessor constant Oculus, enable Oculus is there. Okay, so here is the Unity project of the Quest client. And first of all, we need to check that the preprocessor constant Oculus enable Oculus is there. So let's go to, and it's not there. Okay, so we need to add it. Enable Oculus, apply. Okay. So the next thing that we need to do, we need to switch platform. So because this is an Android, and in order to compile a binary that can be accepted by the Oculus Quest device, we need to build in Android. So switch to that platform. And with this, we have finished with the lesson about VR development. We have prepared the project in order to work in VR. Next, we import the Oculus SDK library and we use it in a new scene where we worked with the Oculus Camera Rig. Finally, we have seen about the preprocessor constants and how you can use them in order to support the development of multiple platforms. And that's what we are going to do in the next lesson. Aside from desktop and VR, we are going to support the mobile platform.